We have seen from the previous groups that we basically changed the approach and the business model from the company by moving from the providing concrete to providing digital service based on concrete, but at the end, way more complex and way more efficient also. The numbers shown in the videos, the percentage of efficiency gain is really impressive. And now we will dive a little bit more into the IP and the IP risk related to this change, because at the end, by switching the business model and by going more and more digital and more in the upper level and upper layer of the digitalization, we figure out that we are not anymore comparing ourselves with the same competitors. And in particular, we are comparing ourselves with technology provider, communication provider, cloud computing solution provider. And we can see on this graph that the explosion of filings related to this matter since now something like 20 years. And so until the point that it reaches 1/3 of the filings in the EPO are about digital patents. So now we have this huge amount of patents that we are not so much concerned about in the previous, let's say, industry or previous business model. And this all of a sudden comes to be a necessity to understand and to take also maybe counteractions or a license on communication technology and so on. We will discover the following in the next slide.
A good example for what happens in digitalization of a sector, of a business sector, is could be found in self-driving cars, so the autonomous cars. When we look at the patents that have been published in between 2011 and 2017, we see that actually only a large third of the applicants are traditional automotive players, and they only account for 40% of the patents on autonomous cars. When we deep dive into the first four, they are actually responsible or owner of the 1/3 of the patents, and they are not even from the automotive car industry. Actually, the digitalization is creating a business ecosystem that leads to new competition. You see that traditional car manufacturers are not the majority of the players in this field. So actually, we see that there are pure software companies without even hardware on car conception knowledge. And there's also competition with the data processing companies, because actually what is really necessary for the autonomous car is actually interpreting and analyzing data. So actually that means that we can't say that the business sector is a concept anymore. It's more and more vanishing, and they become more open to competition. So I'll let continue for my colleagues.
So we now look at the technology contributions by 3GPP members, third generation partnership projects. 3GPP contributions to 2G, 3G, 4G, or 5G. So in the chart, we can see that the number of standard essential patents, SEPs, is growing faster from the period 2010 to 2018. So this leads to higher risk of infringement. The number of standard essential patents increases as these SEPs are needed to comply with technical standards, since standards have to be implemented in the products to have market access. So I now hand you over to Russell.
Thanks, Medina. And so in this use case, if we consider then that the sensor is taking from the physical world the curing of the concrete and moving then from the physical into the digital world through connectivity, so that the analytics can be performed, and then from the analytics further connectivity to allow the reporting of the user benefit, which is the data on the curing of the concrete, allowing enhanced productivity of the user So within the connectivity, as we've seen earlier, then the connectivity will be provided by the cellular standardization of the 5G, and that there's been a considerable number of patent applications filed in 5G, and many of these are considered to be standard essential patents or SEPs in relation to this 5G standardization. Typically, these are held by telecommunication firms rather than the traditional competitors in the construction industry that we'd see from Concremat. And so the way in which we would have to consider SEP patents or SEPs will be considered fun. Thanks.
FRAN is the acronym for Fair, Reasonable, and No Discriminatory. Generally arises in antitrust cases where an owner of intellectual property rights refuse to grant a license on FRAN terms. However, what is fair, reasonable, and non-discriminatory in one context can be unfair in a different context. The exact condition under which a license will be FRAN compliant are not universally accepted. Fair refers to the behavior of the contractual parties in the framework of the licensing negotiation, and reasonable refers to the negotiation results that has to be mutually acceptable. And Pierre will continue with the presentation.
The second company, the second part is reasonable. So that means that we should each partner should reach a win-win situation somehow, where both find advantages to be able to drive their business. And both have obviously benefit that the business will develop and generate licenses revenues. The third condition of the FRAN is a non-discriminatory. So similar condition, companies have same condition. It doesn't mean, in fact, that each company will have exactly the same licensing rate, but at least similar companies should have appropriate and comparable conditions. So these three conditions, somehow we could say, allows at the end to reduce transaction costs. That's also a way to reach an agreement faster on the licensing conditions. And that's also a way to support fair competition. We'll present here three different models to set royalty rates for FRAN licenses. The first one is profit split, so it's a bit self-explanatory. So that's a way where the licensee and the licensor will agree on a way to share somehow the sales, the benefits generated by the sales in a fair way. Now, with this comes a set of questions. Obviously, it's not this easy to define what do we mean by fair. For example, here for the licensor that has invested in creating the technology. Another point to consider also is, are there any other technologies somehow that are needed to realize the solution, because profit in this case might be also shared. And last but not least, what would happen, what would mean reasonable for the licensee in case he can barely generate any profit from this solution. So Ivan will take over with two next models.
Thanks, Pierre. The second FRAN compliant license methodology is the royalty cap. As the name explains here, in the case of the standard, which is made up of different patents, the idea is to identify a maximum royalty rate for that particular standard, which could be made from different patents. So the problems which arise in this case is how exactly are going to split the royalty between each patent, which make up this patent. Should it be divided equally, or maybe due to the technical value and technicality of that patent? How also the royalty cap, so the threshold for that particular standard, is going to be determined. The third compliant license rate is similar to the market value for IP evaluation, which is basically comparing our patent or standard with other licenses available and come up with a market value for that particular license. Issues here are also in terms of how or whether there are comparable licenses we can look at, and also if they aren't, what are the differences with those which are similar to ours. Thank you.